Hello dear students, let's start the part 1 of chapter 8b, study of compounds ammonia of class 10th in subject chemistry. Now in this part we will discuss about the introduction of the ammonia, history for the discovery of the ammonia, occurrence of the ammonia in the nature, and the laboratory preparation of the ammonia. So let's start the topic. About the ammonia. Now ammonia, the molecular formula of the ammonia is NH3 and their molecular mass is 17. You know that the atomic mass of the nitrogen is 14 and the hydrogen is 1. Now the 3 hydrogen in the ammonia, so 1 into 3 plus 14, so total 17. The molecular mass of the ammonia is 17. Now in the ammonia, 1 nitrogen and 3 hydrogens bonded to each other by the covalent bond. Now here the structure of the ammonia. As you know that the nitrogen has the 5 valence electrons and hydrogen has the 1 valence electron. Now the nitrogen required 3 more electrons to obtain their octets, 8 electrons, and hydrogen required 1 electrons to obtain their DOS. So in that situations, nitrogen needs 3 electrons and hydrogen also needs the 3 electrons. So they share their electrons to each other. So one nitrogen sharing with the 3 hydrogens of 3 electrons. So the 3 electrons of the nitrogen participate in the covalent formations with the 3 hydrogens. Now the one pair of the electron remains in the nitrogens which do not participate in the any covalent bond formation. So that remains one pair of electron is called the lone pair of electrons. So in the ammonia, nitrogen having the one lone pair of the electron. Now introduction or history about the discovery of the nitrogens. History of the ammonia, not the nitrogen. History of the ammonia. So ammonia was first prepared by the Joseph Priestley in 1775 by heating sal ammoniac, that means ammonium chloride with select lime, calcium hydroxides. So first the Priestley heating the ammonium chloride with the select lime, calcium hydroxide, and they get the ammonia NH3 as in the form of gas, calcium chloride as a byproduct, and H2O as a vapor. So the ammonia prepared by Joseph Priestley in 1775 by heating the ammonium chloride with select lime, and he named the ammonium chloride as the alkaline air due to its basic in nature. So ammonia having the basic natures. So Joseph Priestley given the name initially of this ammonia was the alkaline air. Now next point, the chemical composition of ammonia was determined by Berthollet in 1785 after 10 years of the Priestley work. So now the occurrence of the ammonia. Ammonia occurs in the nature in free state and also in the combined state. In the free state, the ammonia occurs in the nature in the traces amount in the atmosphere, being formed by decaying urine and other organic matters. So after the decomposition of the urine and other organic matter by the biological organisms, bacteria and fungus, the organic matter decomposes into or changes into the ammonia, and that ammonia present in the atmosphere in the traces amount. Now in the combined state, a small quantity of the ammonia present in the form of the ammonium salt, as in the plants and animals, such as in the plants, such as in the animals' blood and urine, and in the plant in the form of a protein and other ammonium salts, in the rock, in the soil, and also in the mineral water in the form of the nitrite and nitrate. So ammonia also present in the nature in the combined forms, in the form of ammonium salt. It is also present in the form of ammonium chloride. Ammonium chloride is also called the Naushadar, and ammonium sulfate. Now ammonia and ammonium compound being highly soluble in the water, so they do not occur as a mineral. Now the sources of ammonia. Generally, ammonia obtained from the destructive distillation of coal. So ammonical liquor, which is obtained by the destructive distillation of coal. Now the destructive distillation of nitrogenous organic matter such as horn, hoof, bones, etc. of animals. So ammonia can also be obtained from the horn, hoof, bones by their destructive distillations. And another source of the ammonia is ammonical salt. Now ammonia is used in the different forms. Generally ammonia present in the nature in the form of gases, but ammonia also used in the different forms, such as it is used in the form of the gas, liquid, as in the form of liquid ammonia, and also in the form of the liqueur ammonia. Now what is the liquid ammonia? Now liquid ammonia is obtained by compressing the ammonia gas at 6 atmospheric pressures. So first taken the ammonia gas and compress the ammonia gas into a cylinder at about the 6 atmospheric pressures. Then the composition of ammonia will not change, but the state of the ammonia will change, and the gaseous form of the ammonia changes into the liquid form at 6 atmospheric pressures, and that called the liquid ammonia. Liquid ammonia is available in the cylinder, and it is mainly used as refrigerant in our AC, in our fridge and other refrigerants for cooling down the temperature. The liquid ammonia is a saturated solution of ammonia in water. So not the liquid ammonia, but liqueur ammonia. Not the liquid ammonia, but liqueur ammonia, LIQUOR, liqueur ammonia. Now liqueur ammonia, it is a saturated solution of ammonia in water. So when ammonia dissolve in the water, then the maximum amount of the ammonia gas is dissolved in water. That solution is called the saturated solutions, and That saturated solution of ammonia is called the liqueur ammonia. Its very dilute solution is ammonium hydroxide and is used as a laboratory reagent. When the ammonia is strongly dissolved in, when ammonia NH3 strongly dissolved in water, then they react with water and form the ammonium hydroxide NH4OH. NH4OH. And that NH4OH, it is an important dilute solution which is used as a laboratory reagent. Now the preparation of ammonia. Now the general methods for the preparation of ammonia. Generally by heating any ammonium salt with an alkali. So you can take in any ammonium salt such as ammonium chloride, it is ammonium salt, and heating in the presence of the alkali such as calcium hydroxide. Then we get the ammonia. So ammonia can be prepared by the general methods by heating the ammonium salt with an alkali and we get the ammonia. So when heating the ammonium salt in the presence of alkali, they gives the salt of a metals, water and release the ammonia in the form of a gas. As for example, when heating the ammonium chloride, it is ammonium salt in the presence of alkali, calcium hydroxide is alkali. Then heating, then we get the calcium chloride, water and the ammonia. What happens in these reactions? Now ammonium chloride break down into the NH4 plus and Cl minus. NH4 plus again break down into the NH3 and H plus. NH3 and H plus. Now calcium hydroxides break down into their respective ions, calcium 2 plus and OH minus. Now calcium 2 plus combined with the Cl minus, they form the calcium chloride, and OH minus combined with the H plus and they form the H2 and ammonia release as a form of the gas. Now in the next reaction, when ammonium chloride reacts with the sodium hydroxide, it is an alkali. When heating the ammonium chloride in the presence of sodium hydroxides, then they produce the sodium chloride, water and the ammonia gas. Now in the next reaction, when ammonium sulfate, it is ammonium salt, ammonium sulfate react with the calcium hydroxide and alkali. Heating the ammonium sulfate in the presence of calcium hydroxide, they produce the calcium sulfate, water and ammonia gas. So what happens in these reactions? Ammonium sulfates break down into the ammonium salt NH4 plus and sulfate ion SO4 2 minus. NH4 plus again break down into the NH3 and release the H plus ions. Calcium hydroxide break down calcium 2 plus ions and OH minus ions. So calcium combined with the sulfate ions, calcium ion combined with the sulfate ion, and they form the calcium sulfate hydroxide OH minus ion combined with H plus ion, they form the H2O, and NH3 is released in the form of a gas. Now in the next reactions, when ammonium sulfate reacts with the sodium hydroxide is a type of alkali, that is soluble base. When heating the ammonium sulfate with the sodium hydroxide, they form the sodium sulfate and water and ammonia. So in these reactions, when ammonium salt reacts with the base, hitting with the base, they form the ammonia. But one exception, ammonium nitrate is not used for preparation of the ammonia because it becomes explosive due to the formation of the nitrous oxides N2O, due to the formation of the nitrous oxide. So ammonium nitrate is never used for the formation of the ammonia, because when ammonium nitrate will heat it, then it form a nitrous oxide, and nitrous oxides, it is an explosive in nature. Let's see the examples. When ammonium nitrate is heated, then it forms the nitrous oxide. N2O is called the nitrous oxide, and that nitrous oxide having the explosive in nature. So ammonium nitrate is never used for the preparation of the ammonia. So this is the exception. Now next, laboratory preparation of ammonia. In the laboratory, ammonia can be prepared from ammonium chloride and from metal nitrides. So ammonia in the laboratory can be prepared from the ammonium chloride and also from the metal nitrides. But preparation of the ammonia in the laboratory from ammonium chloride is the best way, and it is the common method for the preparation of the ammonia from ammonium chlorides. So the reactant required for the preparation of ammonia in the laboratory from ammonium chlorides. So first requirement is reagent ammonium chloride, dry calcium hydroxide. The ratio of the ammonium chloride and dry calcium hydroxide should be 2:3 by weight. Now the condition and reaction. Condition for this method is, first, select limes should have high ratio to counteract any loss of ammonium chloride due to sublimation. So as you know that ammonium chloride ammonium chloride is a sublimate substance. So when heating the ammonium chloride, the ammonium chloride first becomes sublimated. So to counteract the loss of the ammonium chloride, slacked limes should have higher in the ratio, because during the sublimation of the ammonium chloride, the slacked limes should also lose along with the ammonium chloride. So the slacked limes should have higher ratio to counteract any loss of ammonium chloride. Now the reactant should be in dry and grounded state. That means ammonium chloride and dry calcium hydroxide should be in dry and in grounded state. Now the reactions that taken place when heating the ammonium chloride in the presence of the dry calcium hydroxide. Let's see these reactions. When heating the ammonium chloride in the presence of the calcium hydroxide, ammonium chloride is a ammonical salt and calcium hydroxide, it is a base, alkali or base. Now heating both, then we get the calcium chloride, respective metal salt, water and the ammonia gas, NH3. Now the calcium hydroxide, it is called the slacked lime, is preferred as the alkali because it is cheap. Calcium hydroxide, slacked lime, is cheap, not very costly, and It is not deliquescent as like the sodium hydroxide and potassium hydroxide. Sodium hydroxide and potassium hydroxide, these two are also the alkali, but we can prefer the slack-lime calcium hydroxides as compared to the sodium and potassium hydroxide, because sodium and calcium hydroxide are costly, but calcium hydroxide is cheap. Calcium hydroxide is not deliquescent substance, but sodium hydroxide and potassium hydroxide are deliquescent substance. So we can prefer to choose for this reaction as a alkali, calcium hydroxide as a alkali for the preparation of the ammonia through this method. Now, in this method, the laboratory method for the preparation of ammonia, apparatus and procedures. So first we take in the apparatus and arrange the apparatus according to the given diagram in the slides, in the slide. So let's see this diagram in this slide. Now this one is a wire gauge, this one is a tripod stand, this one is a burner, and this one is a round bottomed flask, and this one is the stand on which the round bottom flask arranged, and this one is a drying tower, and this one is a inverted gas jar. So first arrange the apparatus according to the given diagram in the slide. So first taken a round bottomed flask, this one is a round bottomed flask, and taken the mixture of ammonium chloride and calcium hydroxide in the round bottomed flask, and arrange this round bottomed flask on the stand, on the wire gauge with the help of the stand in an inclined manner, not flat but in the inclined manner, inclined position. The round bottom flask arranged in the inclined positions on the wire gauge with the help of the stand. So first taken the ammonium chloride and calcium hydroxide in the round bottom flask, and that round bottom flask kept in an inclined position, so that during the reactions, after heating, when the reaction will start, the moisture or water forms. That formed water do not trickle back into the hot flask and causes it to break. So we should arrange the round bottom flask in inclined position. Now a delivery tube connect the round bottom flask to the drying tower, and another delivery tube connect the drying tower to the inverted gas jar. When burner will on, then the reaction will start. After heating, the reaction will start between ammonium chloride and calcium hydroxide, and the ammonia will formed, and then ammonia passes through this delivery tube into the drying tower containing the quicklines, and that quicklime absorb the moisture present in the ammonia gas, which release from the round bottoms flask or through the delivery tubes. So quicklime is a drying agent, and that quicklime absorb the moisture from the ammonia gas, and pure ammonia gas that released through these delivery tubes, and the ammonia gas collected in a inverted gas jar by the downward displacement of the air. So the ammonia gas formed in this round bottom flask due to the reaction of ammonium chloride and calcium hydroxides by heating, and that ammonia gas passes through these delivery tubes and come into the drying towers. In the drying tower, quicklime absorb the moistures, and that ammonia gas again passes into the inverted gas jar, and in the inverted gas jar ammonia gas will be collected. So through these procedures we can prepare the ammonia in the laboratory. Now the precaution for the laboratory preparation of the ammonia from ammonium chloride. The flask is kept in an inclined position so that any water formed during the reaction do not trickle back into the hot flask and causes it to crack. So the flask should be taken into the inclined position. Thus, during the formation of the ammonia gas or during the reaction between ammonium chloride and calcium hydroxide, the ammonia formed, along with the ammonia water also formed, H2 also formed. And if water remains in this flask, then the water crack the flask due to their heating nature. So the flask should be kept in an inclined position. That's why the water automatically removed from that flask, not remain in the flask. Now drying of the ammonia after formation of the ammonia gas. During this process, the ammonia gas evolved is passing through a drying tower. That drying tower containing the quicklime, CaO, and CaO is a good drying agent. So drying tower containing the quicklimes, and quicklime absorb the moisture that present in the ammonia, that present in the ammonia gas, which release from the flask. Now Kong sulfuric acid, calcium chloride, phosphorus pentoxide, these all are also a drying agent, but for the drying of the ammonia, these three drying agents cannot be used, because the Kong sulfuric acid, calcium chloride and phosphorus pentoxide reacts with the ammonia and they form another compound. So the calcium chloride, phosphorus pentoxide and Kong sulfuric acid never used as drying agent for the drying of the ammonia. Now the reaction here is Kong sulfuric acid react with ammonia to form ammonium sulfate. So sulfuric acid, Kong sulfuric acid, when react with the ammonia, they form the ammonium sulfate. Next, phosphorus pentoxide react with ammonia to form ammonium phosphate. Now the reactions between them is when ammonia reacts with phosphorus pentoxide, the presence of moisture, they form the ammonium phosphate. Now the anhydrous calcium chloride combined with ammonia to form additional compound. These are the reactions when ammonia combined with calcium chloride, They form the additional compounds calcium chloride dot 4NH3. So due to that reason, the COM-H2SO4, phosphorus pentoxide and calcium chlorides never used as a drying agent for the drying of the ammonia. Now the collection of ammonia. After drying, the ammonia collected in inverted gas jar. Ammonia is collected in an inverted dry gas jar by the downward displacement of air. Because ammonia is highly soluble in water, so ammonia never collected in the water because ammonia dissolve in water. So when we collect the ammonia in waters, then we can't get the ammonia in waters because ammonia is highly soluble in the water. So they react with the water and they form the ammonium hydroxide. Now ammonia is lighter than air. Suddenly the ammonia is lighter than the air. So ammonia can be collected in inverted gas jar by the downward displacement of air. The vapor density of ammonia is 8.5 and the air is 14.5. So air is heavier and ammonia is lighter. Now, in the laboratory, ammonia can also be prepared from metal nitride. So the second method for the preparation of ammonia in the laboratory is metal nitride. From metal nitride. In the laboratory, ammonia is prepared by the action of warm water on metal nitrides of magnesium, calcium and aluminum. So magnesium nitride Mg3N2, calcium nitride Ca3N2 and aluminum nitride ALN. These all from these nitrides we can prepare the ammonia by the action of warm water on this metal nitrides. Ammonia can be prepared. So metallic nitrides, when react with water, they form the metallic hydroxides and ammonia. So for example, when magnesium nitride Mg3N2 react with water H2O, hot water, steam, then they produce the magnesium hydroxide MgOH2 plus NH3. So ammonia gas can be prepared from the metal nitrides by the action of warm water on it. As for example, when magnesium nitride react with hot water, they produce the magnesium hydroxide and release the ammonia gas. Now the next reactions with other calcium nitrides, aluminum nitrides, they react with the warm water and produce the calcium hydroxides and ammonia, aluminum hydroxide and the ammonia. Now the laboratory preparation of the ammonium hydroxides from laboratory preparation of the ammonia from metal nitrides, that means magnesium nitrides. So this is the second method from which we can prepare the ammonia in the laboratory. The reagent required for the preparation of ammonia in the laboratory through this method is first the magnesium nitride and warm water. Now the conditions for the preparation of this for the preparation of ammonia by this method is water should be warm and should be added drop by drop in the magnesium nitride. So water should be warm and water should be added drop by drop on the magnesium nitride for the reaction. Now the reactions that taken place in this method, magnesium nitride react with hot water, they form the magnesium hydroxide and release the ammonia gas. For this method, the required apparatus and the procedure. So first, take in the apparatus and arrange all the apparatus according to the given diagram in this slide. First, take in a flat flask or round flask. This one is a round flask. Arrange this round flask on the stand and take in the magnesium nitride in the round flask and arrange the round flask with a Thistell funnels, that Thistell funnel containing the warm water, and that round flask connected with the drying tower by the help of a delivery tube. This one is the delivery tube. So round flask connected with the drying tower by the help of delivery tube, and that delivery tube is connected to the inverted drying gas jar. Now the procedure. First, take in the magnesium nitride in the round bottom flask and added the warm waters drop by drop in the magnesium nitride in this flask, on the magnesium nitride in this flask. So adding the warm water through the Thistell funnel into the on the magnesium nitride in this flask. When adding the warm water, the reaction will start and they form the ammonia gas, and that ammonia gas passes through the delivery tube and go into the drying tower. Now the drying tower containing the drying agent calcium oxide quicklime. That quicklime absorb the moisture that present in the ammonia gas, and that ammonia gas collected in the inverted gas dry jar by the downward displacement of the air. So ammonia gas collected in this jar. So through this process we can prepare the ammonia from the metal nitride by arranging this apparatus as given in the figure. Now drying and collection of the gas. Since the ammonia gas coming out of the flask containing water vapor, so it is dried over calcium oxide or quicklime. It is a drying agent, and the quicklimes do not have the deliquescent nature. Now the dry gas is collected in an inverted gas jar by the downward displacement of air. Now this method is not suitable for the preparation of the ammonia because magnesium nitride is an expensive substance and also it is unstable compound. So this method for the preparation of ammonia is not commonly used due to the reasons. Two reasons, that is, it is expensive and unstable compound, magnesium nitride. So this method is not commonly used for the preparation of the ammonia in the laboratory. Now the preparation of, next topic, preparation of an aqueous solution of ammonia. An aqueous solution of ammonia is prepared by just dissolving the ammonia in water. But it is not a simple method because ammonia is highly soluble in the water. So when ammonia dissolves in the water, it creates a back suction, because the rate of dissolution of ammonia is higher than, more than their formations. So the dissolution, directly dissolution of ammonia in water is dangerous due to the back suction. So ammonia is highly soluble in water. The rate of dissolution of ammonia is much faster than it is produced. Therefore, a partial vacuum is created inside the delivery tube, resulting in low pressure in the delivery tubes, and that leads to the back suctions. So therefore, a partial pressure is created inside the delivery tube and resulting in the low pressure, and this leads to the back suction. To overcome the back suction problem, we can using the inverted funnel. Now let's see the inverted funnel in this diagram. Let's see the inverted funnel in this diagram. Now this is the inverted funnels, and this is a beaker which is containing the water. Now inverted ring of the inverted funnel just touching the surface of the water, and the tube of the inverted funnels attached with the delivery tube of the ammonia gas. Now what happened in this process? When the ammonia gas passes through the delivery tube and go into the water through the inverted funnels, then ammonia gas fastly dissolve in the waters, and the vacuum created in the tube of funnels or delivery tubes. Due to creation of the vacuum, the pressure inside the tube becomes low, and due to low pressure, the water rises in the inverted funnel and also in the tube of the inverted funnel. And due to rise of the water, the contact between the ring of inverted funnel and water surface will disappear, and after disconnections between the ring of funnel and waters, the air enter into the inverted funnels, and due to the inserting of the air and due to the gravity, the water fall down into the beakers, and that water when fall down into the beakers, again the back suctions will disappear, and then the ammonia get dissolved in the waters and the solution become saturated. So through these methods of dissolving ammonia, we can prevent back suction of water into the flask. So we can prevent the back suction of water that created into the flask. Now next benefits of this method is, now these inverted funnels provide a large surface area for the absorption of the gas. So large amount of the gas dissolved in the waters, and that provide the large surface area. So back suction is also prevented. Now a saturated solution of ammonia in water is called the liqueur ammonia fortis. So saturated solution of ammonia in water is called the liqueur ammonia fortis. So this is all about the introduction of the ammonia, their occurrence, and the preparation of ammonia in the laboratory from the ammonium salt and also from the metal nitrides. How can you prepare? So this is all about the ammonia preparation and their introductions. Thank you to all. Have a nice day.